Hi, welcome to my TED Talk. Today we will be talking about the Sieve of Eratosthenes by me. What is a sieve? It is a mesh strainer for separating wanted elements from unwanted material or for characterizing the particle size distribution of a sample, typically using a woven screen such as a mesh or net or metal. In mathematics, it separates wanted elements of a list or array from unwanted elements and narrows down the list. Who was Eratosthenes? Eratosthenes was a Greek mathematician, poet, astronomer, and geographer. He was also the chief librarian at the Library of Alexandria. He is known as the father of geography because he founded the circumference of the Earth, tilt of Earth's axis, and calculated the distance from the Earth to the Sun. He discovered the Sieve of Eratosthenes, and there is a moon crater named after him. Introduction. The sieve of Eratosthenes is a mathematical algorithm to find all the prime numbers in a certain limit of numbers. It is the most efficient way to find a set of small prime numbers, and it was created in circa 240 BC by Eratosthenes. How does the sieve work? The process begins by determining the number of elements in the algorithm, n. It then runs through the entire list iteratively, beginning at 2, which is the first prime number. It will mark all multiples of 2 as composites, or not prime, in that list. Then it moves to the next number not crossed out yet, in this case 3. It will mark out all multiples of 3 and so on until only the prime numbers remain. This process will continue until p, or prime number, is less than or equal to the square root of the integer number, or p squared is less than or equal to the integer number, at which all possible prime numbers in the set will be left while the composite numbers will be eliminated. There are multiple ways to depict this algorithm, one of which is pseudocode. In pseudocode, the algorithm would look like this. The user would first input an integer. This is the range. The output is telling the computer what to print, which is all the prime numbers between 2 and the integer the user selected. It then creates a Boolean variable for all the numbers in the array to true. Boolean is either true or false, so it makes all of them true. It then iterates through the whole array and changes the values of all multiples starting at 2 to false. It then prints all the elements that are still true, which are the remaining prime numbers. In Java, the algorithm would look like this. It begins in a similar way. It sets the Boolean true value for each element. It then loops through the whole array until the prime number squared is less than or equal to the integer. Then it changes each multiple of the number to false, starting at 2 using an incrementer, so it'll go 2, 3, 4, 5. Finally, it uses an if statement to print out all the elements that are still true, which are only the prime numbers. Usage. Although the only use of the sieve is to find all prime numbers of a list below 10 billion, it is often used in the fields of encryption and dynamic programming, where coming up with lists of numbers and factors of those numbers is useful and important. Dynamic programming is a method that simplifies a complex problem into its recursive subproblems and can be used in fields such as economics and aerospace engineering. Now I will show you an example using a set from 1 through 30. Let me get my pen out. So I will begin by crossing out 1 because 1 is technically not a prime number. 2 is the first prime number, so I will circle that. Now, the next step is to cross out all multiples of 2 after. So 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and 30. Now we move on to the next prime number, which is 3. So then we go on to cross out all multiples of 3. And you have to ignore the ones that are already crossed out, like 6, 9, 12, 15, 18, 21, 24, 27, and 30. Now we move on to the next prime number, which is 5. So we cross out all multiples of 5. So 10, 15, 20, 25, then 30. Now, we stop here because 7 is the next prime number. And as the rule said before, p has to be less than or equal to the square root of n, which is 30. And 7 squared is 49, which is greater than 30. So all remaining numbers are prime numbers. So 7, 11, 13, 17, 19, 23, and 29. So these are all the prime numbers within 1 through 30. That's my presentation, so go ahead and take the quiz after. Thank you.